Okay, I think we should start with today's session. So, hello everyone, a very good afternoon to all of you, dear authors and all the invited guests. A very warm welcome to Technical Session 4A. Myself, Yashita, and I'll be your moderator for this session. I'll make sure that everything
Yashita,
will
you are not
run.
audible. I think there is some concern with your mic or like that. Can you please check and
I
One
can
second.
hear well.
no, you are not audible.
Actually, everybody is hearing me well.
Uh,
I can
Vibha
see,
ma'am, is
I
she
can hear.
audible?
Yes, I am audible.
Yes, she is audible.
Yes.
Yes, you are. You are. Yes,
Okay,
Yashika, please go.
yes. So myself, Yashita, and I'll be your moderator for this session. I'll be making sure that everything will run smoothly and maybe try to keep up the energy. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the International Conference on Technological Intelligence and Business Strategies, which is TIBS 2026. Manila, Philippines. This conference is being organized in a hybrid mode. The physical event was held yesterday in Philippines, and the virtual event is being held through Zoom on 23rd and 24th June, where people from all over India as well as from other countries are present with us. I hope that you all will enjoy today's insightful and knowledgeable sessions. So, in this session, we will be having 8 presentations. Each presenter will be given 10 minutes for presentation, followed by 2 minutes for question and answers. So, I will give a gentle reminder at the 8-minute mark just to help everyone to keep up with the time. Also, a small request to all the participants that please stay connected with us till the closing remarks. I promise that it will be worth it. So, if you have any queries or updates, please feel free to drop them in the chat box anytime. Me and my co host will be assisting you regarding it. So, before we begin with our presentations, I would like to introduce you all to our esteemed session chair. First, we have Dr. Peppa Petrova, who is in Chief Assistant Professor at the University of Library Studies and Information Technologies located in Bulgaria. Her scientific interests include data analytics, data storage, data visualization, business intelligence, artificial intelligence, machine learning, and information systems. She also brings over 10 years of experience in real world business projects, reflecting a strong blend of academic research and practical industry engagement. So, welcome to the session, Petrova ma'am.
Hello, everybody. Thank you so much. Good afternoon to all distinguished colleagues and participants. Thank you so much for being on time. I'm delighted to welcome all attendees from different countries and different institutions. And I look forward to learning and hearing from today's presentations and the insights they will provide. So let's get started with the first presenter and the first paper. Thank you.
Thank you so much for those words. So, next we have Dr. Bindya Jain with us. She is an assistant professor in the Faculty of Computer Science and Engineering at Purnima University in Jaipur, India. Her research interests are generative AI, green AI, human machine interaction, and IoT, contributing to research and faculty development programs. She is recognized for her work in computer science. So, Bindya ma'am, welcome to the session. Would you like to say something?
Thank you so much, and all the best for all the participants so that they can give their best and take your time and make sure your relevant work you should show in your presentation. What you are done in your research era, you have to show. This is my request to all the participants. Thank you.
Thank you so much, ma'am. So, we will move forward with our first presentation for today. We have with us Ripu. Are you there in the meeting? Let me check once. Okay, I think any of her co-authors is present. Okay, so we will move forward with the next one. We have Shreya Shukla. Are you there in the meeting?
Hello, yes, I am here.
Yes, so she is here to present her paper titled as ADHD classification using vision transformers and deep learning, a survey of fMRIs, SMRIs based diagnostic approaches. So Shreya, you can start sharing.
Yeah, sure.
Yeah. Guys, let's make this session interactive as we are connected virtually. So I request everybody to get involved, ask questions. Shreya, are you ready with the present? Yes.
Just give me a second. Yeah, should I start? Okay. A very good afternoon to everyone present here. Myself, Shreya Shukla. Currently, I'm a student in Manipal University, Jaipur, India. I am here to share my paper titled ADHD classification using vision transformers and deep learning. It is a survey paper that uses fMRI and SMRI based diagnosis approaches. So, rather than presenting a single new model, my objective for today is to trace how this field has evolved over the past decades to identify what currently represent a state of art and to highlight the open challenges that remain before these methods can move from research into clinical practice. So, yeah, let's begin with the presentation. So, ADHD is one of the most common neurodevelopmental disorder affecting roughly around 5 to 7% of children's and 2 to 7% of adults worldwide. So, right now, ADHD is still mostly a judgmental call. A doctor watches a child's behavior, talk to parents and teachers, and fill out a checklist. There is no proper blood test, no scan, no objective number. So, because it depends on human judgment, two different doctors can look at the same child and reach to two different conclusions. We also know that this lead to real bias because as we know all doctors can have different opinions, so it also have a gender bias. Like for example, if a girl child has ADHD or a boy child has ADHD, then the opinions will differ for both. So the question is, what if we could look inside the brain itself instead of just watching the behavior from the outside? That's exactly what neuroimaging offers. Think of fMRI as watching the brain in action, like which regions lights up, which opens, and which don't. So, if we just take a snapshot of brain scan and put it into the model, and it can give us the result rather than just the clinical assessment or a behavioral assessment, then that will be more beneficial for the children's or the ADHD patient. So here is the catch, like how neuroimaging based classification work. We just put a MRI scan that then it will be pre-processed through different deep learning models such as CNN, VIT or the hybrid approach. Then the performance evaluation happen through accuracy, AOC curve or F1 score. Then we can diagnose if a person had ADHD or not. Let's move to the next slide. Yeah. So, how did researchers first try to teach a computer see like ADHD is a brain scan? They started with CNN, that is the first model used for ADHD diagnosis. The same technology behind facial recognition and self-driving cars, which works by scanning the brain region by region, looking at what's nearby. So in 2012, Chang got it working around 62% accuracy, barely better than a coin flip. But over the next decade, things improved fast. In 2019, Mao were analyzing full 3D brain volumes instead of flat slices, hitting around 75.6% accuracy, and so on. So that's the real progress. But here's the catch: CNN only understand what's close together. They are not excellent at they are only excellent at local details, but they generally struggle to connect two regions on opposite sides of the brain. even when those regions are working together also. So that's a problem because ADHD is not a one spot issue. It's a breakdown in how distant brain regions can communicate with together. So as good as CNN got, they were hitting a structure calling, and that's exactly the push we need. So we went to another model that's better than CNN for ADHD classification, that is vision transformers. So, if CNN were stuck looking at things close, what changed into 2021? Researchers borrowed an idea from a completely different field, the same vision transformer technology behind some of the most advanced image recognition system, and adapted it for the brain. Instead of just looking at what's nearby, a vision transformer look at the whole brain at once, and every regions talk to every other regions directly, no matter how far apart they are. So, researchers then went a step together in two directions. First, multimodal fusion that combines fMRI and SMRI images and even more scans typed together, which research 88.9% accuracy. And the best approach among this is the hybrid model that combines CNN plus vision transformers that have the best accuracy as of now for ADHD classification, because it combines local feature as well as global features. Let's move to next slide. Yeah. So this slide covers how we structured this survey. We conducted a structure review of deep learning approaches for ADHD classification from 2012 to 2025, organizing the literature into three models categories: CNN, vision transformers, and a hybrid that uses both of them. So our review scope was limited specifically to functional MRI and structural MRI studies, and our comparative analysis compared dataset, pre-processing pipeline, and reported results with the goal of drawing insights from all of them. While we covered the full 2012 to 2025 window, our primary focus is on the vision transformer era, because since that was the field that is moving so fast and more accurate for ADHD classification. Yeah, let's talk about the data behind all of this. So a handful of dataset dominate these field, but what we use for our survey is the ADHD 200 dataset. That is the gold standard. Nearly 1,000 participants specifically labeled for ADHD. The other dataset that are available are ABCD, UK Biobank, HCP, etc. That are much larger than ADHD 200 dataset, but they are used for pre-training rather than just for the model diagnosis. Sorry. Yeah. So this is the pipeline how we conducted ADHD to in the if CNN and vision transformer look at the same scan, why do we need such different inputs? Every scan starts the same way, like shown in the purple: motion corrected, skull stripping, resized, filtered, and a standardization. So scans from different hospitals are actually comparable. Think of it as like the cleaning the photo before analyzing it. Then the path splits, like a CNN part as a full 3D volume. It scans the grid directly. Then vision transformer gets something different, like the brain is sliced into small patches and turned into a sequence, almost like a cutting photo into puzzle pieces. Each one labeled it with a different labels. That's because the transformer don't read a 3D grid, they read a sequence of pieces they can compare against each other, which is exactly how they connect distant brain regions in the first place. So this is one of the picture really explains why two models can look at the identical scan and see completely different things. Yeah. So yeah, this slide really captures the core idea of the whole paper in one sentence. CNN can see the local details, while vision transformer can see the whole brain at once, and the hybrid can do both of the things. CNN can apply convolution layers that are excellent at picking up fine-grained images, localized patterns. But as we discussed, they are blind to relationship between distance regions. That's why VIT comes in. VIT flips that. VIT uses self-attention, like every patch of the brain can attain to every other patch, regardless of what is the distance. That's a much more natural fit for a disorder like ADHD.
Shreya,
So,
sorry to interrupt. Just a quick reminder that you have to wrap up within next 1 minute, one to
okay,
2 minutes. Yes.
yeah. Then the hybrid model comes in that combines the advantage of both the models, CNN and VIT. It can capture local images from CNN and global images from VIT. So that's the best model among the all three. On this slide, there are some numbers like uh, taking the best result from each architecture family from the ADHD 200 dataset. CNN topped out with 84.2% accuracy. Then VIT, which is the highest accuracy VIT got, is 88.9% accuracy, and hybrid got 89.1% accuracy. Take the metrics that we use to compare this is accuracy, precision recall, FN score, and ROC AOC curve. Yeah. So stepping back, what does the overall scoreboard actually look like? Like the bar chart sums it up at a glance. CNN peaks in the low 80s, while VITs and hybrid both push closer to 90%. That's a real consistent gain, not a one-off result. So the two best performers right now are Brainformer at 89.1% accuracy and MMM Transformer with 88.9% accuracy. So why do VIT win? That's the main question. Like why do Vision Transformer are winning again and again? Because there are three reasons. The first is they see the whole brain, not just the nearby regions. They benefit a lot from pre-training, which matters since labeled ADHD data is limited, and hybrid combining both result global and local views. So they are giving consistently the best results. So in one line, if we say, then we can say that hybrid is beating vision transformers and vision transformer are beating CNN. So in this slide, we just talk about advantages and some of the challenges that we face. The advantage is that CNN are having 84% accuracy overall, but if we use the multimodal, the hybrid approach, then we are gaining 89% accuracy. So hybrid model works the best among all the models, but there are some of the challenges also. It's hard to explain why a model made a particular decision. Like in healthcare, that matters a lot. Why a model is acceptable in any hospital or situation. We are also working with very few labeled patients under 1,000 in larger data set. So these models need real computing power to run, and results can shift when you move from one hospital scanner to another. So be honest that the accuracy is there, but trust, data, and inconsistency is still needs to be worked on to move from research into clinical use. So there are some of the key findings from our survey paper that VIT and hybrid can beat CNN, and self-attention is all we need for ADHD diagnosis using some deep learning models. Uh, and these are some of the future research direction that we can move to, like foundation models pre-trained on large amounts of unlabeled brain scan, federated learning which lets multiple hospitals train one shared model without even scanning actual patient data, and multimodal fusion combining functional MRI and structural MRI scans into one place. So in the bottom line, deep learning is closing the gap towards objective ADHD diagnosis, but an actual part to clinical use are still the two biggest open challenges. And the line I want to leave you with this, that AI should support clinicians, not to replace them. So these are some of the references from my paper, major references that I used in this PPT. Yeah, so with this, I want to close. Thank you so much for having me, and I'm glad to have any questions.
Okay, do any of the session chairs have questions for her? You can go ahead with it.
Yes, hello. Thank you so much for the wonderful presentation. Shreya, you already mentioned some of the challenges that you faced during the research. What do you think would be the greatest barrier to clinical adoption of your study? That's my question.
Yeah, ma'am. Thank you so much for having the question. I think the greatest barrier for adopting this model into clinical study will be that there is not a much labeled dataset available. Like the dataset that I used was ADSG 200, but in that dataset, most of the rows and columns have male dataset part more. Like 80% was the male dataset part and 20% were the female dataset part. So if we apply that data set into a model, then the model can be biased towards our specific gender somehow. So that's the biggest challenges I think we have to get the data set that will combine both gender specificity. Yeah.
Thank you.
Yeah. And thank you so much.
Okay, Shreya, come on your slide number 5.
Okay, ma'am. Are you talking about this, ma'am?
Show me your, yeah, next, previous one. Okay.
Yes, ma'am.
So, neuroimaging data set you are using over there, and the path you are following. So, can you explain this path, how your data set will be applicable in this path, and what the resulting content you find?
Sorry, ma'am. Can you like explain your question a little more?
हाँ, I want to say that कि आपने अपने इस डेटा सेट में ये जो पाथ आपने फॉलो किया है, जो आपने प्री प्रोसेसिंग दिखाई है,
Yes,
इसमें किस तरीके से आपने इस पाथ को अपने डेटा सेट को काम में लिया, और फिर उसका रिजल्टेंट आपको क्या मिला? आर यू गेटिंग माई पॉइंट?
yes, ma'am, I'm getting it. Thank you so
Okay.
much for having the question. Ma'am, actually, I had done a survey paper rather than a research paper. So it is a pipeline that I got from the paper I stated in the reference that having 89.2% accuracy by using vision transformer, that is the best model among all. So it's a pipeline from their paper that they used and got the best result among all the models. So yeah, as I done survey, I don't have a specific model for myself.
फिर
I
इस
just,
डेटा सेट का यूज क्या हुआ?
ma'am, they use this data set for their
All
research
the
part. I
references
just
are using
replay.
this data set. Are you
Yes,
saying like this?
yes, ma'am.
Okay, fine. Okay, thank you.
Yeah. Thank you so much, ma'am.
Thank you so much for your presentation. So, with us next, we have Sai Zadhav. Are you present here, Sai?
Yes, I'm there.
Okay, so Sai is here to present her paper titled as AI powered multi-agent self-evolving cybersecurity intelligent systems. So Sai, you can start.
Yes.
Yes.
Is the screen visible?
Yes, it is visible. Please do it in the presentation mode. Also, I request
Yes.
all the authors to please stick to the time as we are time bounded and complete the presentation within 10 minutes so that it is easy for everybody to manage the time. So you can start.
Yes. So good afternoon, everyone. I'm Sai Zadhav, a student at Vishwakarma Institute of Technology, Pune. And today I'll be presenting our project titled AI-powered multi-agent self-evolving cybersecurity intelligence system. So, as cyber attacks continue to grow in sophistication and frequency, traditional security systems struggle to keep up with evolving threats. So, our project addresses this challenge by combining AI, ML, and threat intelligence in a multi-agent system to create an adaptive cybersecurity framework which is capable of learning and detecting and responding to threats in real time. So let's begin with the actual problem statement and the motivation behind this work. So uh, these are the points that I'll be covering in the slides coming ahead. So cybersecurity has become one of the most critical concerns in today's digital world. So organizations generate enormous volumes of network traffic every second. So hidden within these traffic are malicious activities such as the DDoS attacks or port scanning, brute force attacks, malware intrusions. So traditionally, cybersecurity systems rely heavily on predefined rules and signatures. So the major problem with these approaches is that they can only identify threats they already know. But when attackers create new attack problems, systems often fail. So, additionally, security analysts must manually inspect huge volumes of data, which makes detection slow and resource intensive. So, to solve these challenges, we propose an AI powered multi agent self evolving system. So, our system continuously monitors data. It identifies suspicious behaviors and it learns from new attacks, which further enhances and improves its performances and automatically with minimal human intervention. So this creates a more adaptive and intelligent defense mechanism against modern cyber threats. So the motivation for this project comes from several real-world cybersecurity challenges. So first is the cyber threats, which are becoming increasingly sophisticated. Attackers continuously develop new techniques to bypass traditional security mechanisms. Second, being the most security solutions require extensive manual analysis, which increases response time and operational costs. Third, organizations generate massive amounts of unstructured security data, which makes it difficult for human analysts to process everything efficiently. So finally, modern security environments require an actual real-time threat detection and automated response capability. So these challenges is what inspired us to develop an intelligent system which is capable of autonomous analysis. So for this system, we did a thorough literature survey. So we studied the existing cybersecurity approaches and the research works that have been done on these. So many traditional systems are still based on the intrusion detection systems, which rely on signature-based methods. So while these systems perform very well for known attacks, they struggle against the new attacks and not previously unseen attack patterns. So researchers, there are different research papers that I've included. So some of these include their focus on random forest, decision trees, SVM, and neural networks. So these approaches significantly improve detection accuracy, but most existing implementations use only a single machine learning model and they lack collaborative decision making. So recent studies also promise that these systems often focus on specific attack categories and do not integrate live threat intelligence feeds. So we have added this main factor, that is a self-learning, which solves the major challenge. So based on this survey, we identified the need for a system that combines multiple intelligent agents, machine learning, real-time threat intelligence, and continuous adaptation into a unified cybersecurity framework. So the research gap that I talked about right now basically focuses on the first being the most systems use static rule-based detection methods. So these methods cannot effectively identify new and unknown attack patterns. Second being traditional solutions often rely on a single machine learning model, limiting adaptability and robustness. Third, manual threat analysis delays. So this basically the continuous learning and model evolution are generally absent in the current systems. Fifth, being the real-time cybersecurity intelligence, such as the CVE databases and security news feeds, are rarely integrated into a threat detection system. Finally, there's a lack of multi-agent architectures where specialized agents collaborate for detection, analysis, response, and learning. So our project aims to learn and address to all those limitations. So our project basically is a our primary objective to build this project was to design a multi-agent cybersecurity framework and to integrate different models of machine learning for accurate attack classification. It is also the main objective is to utilize real-time threat intelligence by combining two or more devices together to evaluate scalability and performance under dynamic attack scenarios that we have simulated an attack scenario as well. So to benchmark system performance against standard cybersecurity datasets and to create a resilient and adaptive system capable of evolving with emerging cybersecurity threats. So to develop this system, we use multiple technologies. For programming and ML models, we used Python. For data processing and analytics, we use the libraries such as the Pandas and NumPy. For ML models, we use the scikit-learn. For visualization, we use the Matplotlib, Seaborn, and Plotly. For system monitoring of the respective devices that we integrated for this simulation, we use the PSUtil library. And for threat intelligence collection, we use the databases such as CVE database, Security News APIs, and also we use synthetic databases to test it on our respective systems. And for reinforcement learning, we have used the Q-learning algorithm. So let's further talk about the system architecture. So in our system, as it is a multi-agent design, each agent performs a specialized task while collaborating with others. So the first is the data collection agent. So the first agent collects data from network logs, the system activity logs that are present in a system, the security data sets, and the threat intelligence feed. So our system is also flexible to any data set that can be uploaded onto a system, and it can extract the important columns and the factors that are necessary for the prediction of the cyber attacks. So next is the pre-processing agent. The collected data is cleaned and transformed, which include the tasks such as missing value handling and feature extraction, data normalization. Third is the threat detection agent. This is the core machine learning component. The trained model analyzes incoming traffic and classifies activities such as normal or DDoS or port scan or brute force or botnet attacks. Fourth is the threat intelligence agent. This agent continuously fetches the latest CVEs, the latest cybersecurity news. So this ensures like an awareness of emerging vulnerabilities and attack trends. Fifth is the reinforcement learning agent. So this agent learns from the previous decisions, and this works as a self-evolving agent. Over time, the agent improves decision making and response strategies. Sixth is the response agent. So based on the detected threats, the response agent generates recommendations such as blocking suspicious IP addresses, monitoring critical ports, or alerting the administrators. So the last is the visualization dashboard, which basically for the users, it shows the attack trends or the system performance or the threat statistics or the intelligent updates. So now let's discuss the results obtained from our implementation. So the system achieved approximately 85% detection accuracy across multiple cybersecurity data sets. So the machine learning models successfully identified major attack categories, including the DOS attacks, the DDoS attacks, port scanning activities, botnet behaviors. The system monitoring module effectively detected CPU spikes, suspicious port activities, and the S1 flood patterns. The threat intelligence agent was successful to retrieve the latest CVEs, vulnerability reports, and security news updates. So these visual analytics generated timelines can clearly highlight the attack and behavioral patterns. Additionally, the automated response agent generated actionable recommendations, which will help the administrator of the system to respond faster to security incidents. Next is the future scope. So this is the images of our results as well. Yes, so the current system performs well that we have developed, but several future enhancements are possible, such as direct integration with the live network traffic. Advanced deep learning models can be used, such as CNN, LSTMs, and transformers. Right now, we weren't able to achieve this due to the resource constraints. Next, we can also platforms like AWS, Azure, and GCP. We can also add explainable AI for transparent decision making, and this can further be enhanced by multi-network monitoring across large organizations. So to conclude, this project demonstrates, sorry, these are the references that we have used, that we have referred to for building a system. So to conclude, this project demonstrates the effectiveness of an AI-powered multi-agent self-evolving cybersecurity intelligence system. So by integrating these aspects, we have improved threat detection, faster response times, and continuous learning capabilities, and has reduced dependency on manual analysis. As cybersecurity attacks continue to evolve, the system is quite necessary and will play a crucial role in protecting digital infrastructure. Thank you.
Do you have any questions, ma'am, for her?
Yes, I have question. Thank you, Sai, for your presentation. I was wondering, can you share with us what's the coordination mechanism between the three agents that you mentioned and explained to us?
Yes,
So
ma'am.
thank you.
Yes, ma'am. So the system primarily uses three collaborating agents, such as the threat detection agent, which monitors the incoming network and system data. So it gives an output that is the attack type or the confidence score or the severity level of this attack. So the next agent, that is a threat intelligence agent, it fetches the cybersecurity information and fetches the latest vulnerability databases and security news. This gives an output whether this severe threat has already been recognized in any of these databases. So next is a response in the learning agent. So with this, the prior information, with considering the prior information, it receives the input from both of these agents and it decides the appropriate actions. So the output of this agent is particularly the security recommendations or what actions the administrator or the user can take for this particular attack.
So they are like one-to-one sending messages and exchange information, or they share the same environment.
So, ma'am, these are interlinked. So, basically, when it's like a pipeline. So, when a data is fed
Yeah.
into the first agent, it fetches from it what exactly the severity is, and likewise, it follows up to the next agent as well.
I have one more question. It's very interesting topic. Thank you so much. Have you tested actually this setup with some unseen attacks? You mentioned that is designed mainly for unseen, unknown attacks. Have you tested it with such unseen attacks and how actually the system reacts and
Yes,
replies?
ma'am. So we actually are a group of four students. So we tested it with our individual devices. So we collaborated using the IP addresses. So we connected our devices. And so every device is unique and different from one another. One has a different operating system. So we tried to simulate an attack which would basically it would give the action plan for those particular attacks as well.
Thank you very much. Thank you.
Thank you, ma'am.
Okay, can you explain what is part of your work?
Sorry, ma'am. Can you repeat the question?
Your work in your paper.
Yes, ma'am. So we have distributed the project in parts such as the multi-agent system and the cyber ML part. So I have done the machine learning part where we have used the random forest part. So I have written down my contribution as in the usage of the random forest algorithm and how it is proved to be the best achieving accuracy.
Makes this you are using some data sets and algorithm. So
Yes,
that
ma'am.
based on these algorithm, you execute your work.
Yes, ma'am. So we have collected multiple databases and also we have created a synthetic database as well to simulate the attacks.
Okay, so find how you find the conclusion, because multiple data sets you are using, then how the accuracy will be generated. Here you are presenting like accuracy is 85%. How you
Yes, ma'am.
calculate it?
Yes, ma'am. So one of the standard databases that we used, this system was also tested on multiple environments. But for this research paper, we tested on this standard database and on which we used the random forest algorithm. And that's how we got this 85% accuracy.
Okay, thank you.
Thank you, ma'am.
Thank you so much, Sai, for the presenting. So for our next presentation, we have Elmar Noke to present his paper titled as Big Data Survival Analysis of Breast Cancer Patients using the Metabrick dataset and Hadoop infrastructure. So, are you present in the meeting, Elmar?
Yes, hi. Good afternoon. I'm
Good
present here.
afternoon. You are ready?
Yes, I'm
Yes,
ready.
so you can start with. Present.
Okay. Apologies on my voice. I think I have my tonsillitis occur, so I can probably try to speak slower. So if I'm on my time, just let me know. Okay, let me share my
Yes, sure.
screen.
I will be giving you the reminder. Don't worry at all. Yeah.
Thank you. Thank you so much. Okay. All right. So there you go. So can you see my screen right now?
Yes, it is visible.
Okay. All right. So, good afternoon. So basically, breast cancer remains one of the leading causes of mortality among women. Okay, which is why reliable survivors prediction tools are so important. Now, this study applies big data analytics and Cox proportional hazard regression to the MetaBreak datasets, which holds the clinical, pathological, and genomic records for over at least I think the data set that I have is 2,000 breast cancer patients. This has actually been uh, it's an open source for Kaggle. And Hadoop or HDFS was used to distribute the storage and the PySpark for processing, while the Cox model identify which factor significantly affects the survival. So from the analysis of six significance predictors emerge, this is what happened on our study. So this is co-authored by me and Dr. Randy Joy Mentayan for Unitary International University. So the study pairs a distributed big data pipeline with the interpretable survival statistics, basically. The meta break records were stored in Hadoop, okay, on HDFS, and then it transformed into PySpark and analyzed with the Cox proportional hazard model. Then the cohort holds over 2,000 patients for the datasets. So 25 candidates variable were reduced to at least six significance predictors and inferred in menopausal states was, the strongest risk factor with the hazard ratio of 1.0. Okay, it's very significant threshold of 0.05 was, applied throughout. So the core contribution is that the combining Hadoop-based infrastructure with the interpretable survival modeling can support patient risk satisfaction. The treatment planning and other precision probably in oncology as well. So by this, survival analysis examines the time to event outcomes such as the death or reoccurrence and its proper handle sensors, patients who are still, alive at the last contact or loss to follow up. Okay. So breast cancer is a major public health concern and, leading cause of death among women. So identify the factors that influence survival is, most important for the treatment and plan the risk assessment as well. So the study specifically aims to identify significance predictors, estimate their hazard ratios, test the proportional hazards assumptions, and interpret the findings for patient risk stratification. And now, the MetaBreak cohort from the Molecular Taxonomy of Breast Cancer International Consortium was drawn from the study of Perea and the co-author of it, and assessed through Kaggle. Okay, that's the data set where it came from. It contains clinical, pathological, genomic, and survival information of over 2,000 patients. So the meta break was chosen because it's a large sample size, basically, supports multivariate regression, and its variable cover both clinical and molecular subtypes and includes the overall survival time and events of status of the Cox regression requires as outcome. Now, the analysis runs into three stages. Okay. So Hadoop, okay, HDFS provides the distributed storage where Metravik dataset was ingest as a cancer underscore new.csv. That's the name of the file through a terminal command. And PySpark handle all pre-processing, taking advantage of its distributed execution, manage missing values handling, cleaning records, scaling, and checking all the datas. And then finally, the Python Lifelines library perform the Cox proportional hazard, basically the modeling, okay, the residual test and the survival curves together with the scalable, reproducible workflow from the throughout the visualization, something like that. So next one. Okay. So all pre-processing was carried out in PySpark across 5 steps. So first, record with the missing values were drop, diagnostic, pass, assess, and extend on missingness. Second, the column headers, standardized non-numeric columns where labels are encoded into integers since the Cox model works only on numerical inputs. Third is the patient vital status where the record matches the event indicator and convention that liveness specs with the unknown causes or excluded. And then the fourth is numerical features where scaled with the standard scaler. So like a variable like a tumor size will not be dominated by its magnitude alone. So the fifth is collinearity was handled by computing Pearson correlation and removing redundant predictors to keep the model stable. So the Cox proportional hazard model was used because it's actually estimate the effect of multiple predictors on a survival without requiring fixed baseline hazard. A hazard ratio above 1.0 indicates the increased risk, while a value below 1.0 suggests a lower hazard. The proportional hazard assumption was tested using, Schofield residuals and variables with values above like 0.05 were removed. The Sapero wealth test was applied as well to the survival times, returning W equals to 0.953 and p value below 0.005, confirming the data depart from normality. This is expected and pose no problem for Cox regression.
Elmar, just a little reminder that you'll have to wrap up in 2 minutes. So, what you can do is you can just summarize the whole research in the next 2 minutes.
All right. Thank you for reminding me. Okay. So basically, so this is the widely varying follow-up across the cohort, actually. So just to give you heads up on this one. So the forest plot displays the hazard ratio and 95 confidence interval. So for 6 predictors on a final model that we have, we're actually on the confidence level of like a 1.0 reference line, as you can see. So menopausal state sits on the right to the line, indicating that it is elevated risk. So for the process that we did, okay, the each 6 predictors that we have, as you can see on the screen, into a clinical meaningful dimension for breast cancer. Inframenopausal states is about 50% higher mortality risk of postmenopausal patients, pointing to the role of hormonal factors. So that's actually the result of it. Okay. Now for the findings that we can support on it. Uh, making it identified linked to survival on tumor size, surgical approach, and other stuff like that. The risk model built those predictors that could actually help the flag on it. So for the limitation and the future work for this study, and its boundaries and where it goes next. The study have similar limitations. So Metabrick is retrospect data set. So bias from missing data, selection effects, unsure counter founders cannot be fully avoided. That's an honest boundaries on it. Some variables violated the proportional hazard, but basically, it actually worked. The data set primarily represents European population, so those 2,000. So that's actually it. So for me and the future work, probably we can have a test of effects and combine metaphor for TCGA or SE Asian diversity as well, not only in European, and explore hybrid Cox deep learning survival, or we can probably have the perspective validation on the real world samples for clinical deployment. So the study identifies the predictor associated with breast cancer. So overall survival model on clinical data can be useful for every disease, not only breast cancer, but for using data analytics, cloud-based data analytics, it will actually help a lot for decision making as well and report visualization. So that's it for me. I'm ready to answer some questions that you would like to, ask. Thank you.
Thank you very much. I have questions to you. Actually, I was wondering two things. Why did you choose Hadoop as a distributed system? And did you have your own Hadoop, or you use it as a service from AWS, for instance, or somewhere else? And the next question is, how actually did you handle with missing data? You
Mm.
mentioned that this is your first step in the process, but do you have like values that you replace or fulfill the missing values, or you exclude them from the analysis and future calculation? So what was actually the main approach with missing data? Thank you.
Yeah. The first question, probably why we choose Hadoop for it. It's because for me as starting on venturing other uh, big data analytics on the cloud. Hadoop is probably one of the things that I need to work on. Like I'm just trying to explore Hadoop basically for big data because they said that that particular application or big cloud data can actually help me a lot on big datas, but it's having difficulties running on my computer right now, but we did survive it, so that's the reason why. So for that's what we choose Hadoop on it, because we're trying to see how cloud data works on data analytics. So the second one is the missing data. So you're correct. We did have biases, honestly, because the data that we got is from Kaggle and there is a missing data. So what we did is we just try to, patch things out, and the result basically give us a valid result based on the review of literature that we did as well. So that's why we included on the paper that there are some limitations on the data set. So I think how do we did that? We just make sure that for data privacy and other data laws that we have here in the Philippines, we comply on it. So that's why. Thank you, ma'am.
Thank you very much.
Okay, Bindya ma'am, do you have any questions for him?
No more questions. questions.
Okay, thank you so much, Anwar, for your presentation.
Thank you.
Yes. So our next presenter is Pat Lee Tan. Are you present?
Yes, I'm here.
He is here to present his paper titled as ECG-based cardiac arrhythmia detection and classification. So are you ready with the presentation?
Of course. Okay, I will start right now.
Yes, you can start.
Could you see my screen?
Yes.
Okay, so okay. Hi everyone. Welcome to our sessions. I'm Faculty Teng. Today I will be presenting our research on ECG-based cardiac arrhythmia detection and classification, and in addition, a project co-authored with the Minh Nguyễn Kiều and Phổ Nguyễn Thị Kim, and we are come from the University of Information Technology, Ho Chi Minh City, Vietnam, and let's dive right into our approach for assessing this clinical challenge. Okay, first of all, we come to the table of the contents. There are four main points that I want to focus. Introduction, our proboscis method, result, and the last one is conclusion. So we move on to the introduction. First of all, we identify the challenge like the hospital are generating massive ECG data every day. So, and the doctors rely on manual diagnostics and which waste a lot of time and require many labels. So this leads us to the research gap. So, and this is uh, raising a need for um, deep learning solution. And to fill the gap, we have the topic objective. There are two forms. The first one is we want to build the automated and robot ECG cardiac arrhythmia classification system. And in doing our method, we want to convert the ECG signal to the image, yeah, in classification. And the last one, we apply the DNS 201 for classification. Okay, and we come to the main point, our robustness methods. I want to talk about the data sets in details. With the data sets CBSC 2018, which originates from the China Physiological Signal Challenge 2018, and this is a robust and diverse the data sets because it collected from 11 different hospitals in the China, and in the total we have the 6,877 records with the 12 list ECG, and it's assembled at a high frequency 500 Hz, and there are two types of file in this the data set. The first one is the header file. It store the metadata, and the last one is the MATLAB file. We store the ECG signal as a numeric, the magic. And the next one, when we have the general information about the data set, we need to put it into the main process. The first one is the signal pre-processing. So you can see in this, in the right side, we have the raw ECG signal. So you can see the ECG signal has many noise and baseline water. So when we apply the signal removal with the bandpass filter, spine removal, and SWT cycle spinning, so you can see the noise are eliminated and the external morphological features are resolved. And after that, we normal the signal by z-score method. Yeah, after we put it into the training process. And the next one, after we normal the signal, we divide the signal into the many segments with each segment has a duration of the 10 seconds, and we also use the new technique is 50% overlap in during dividing into the many segmentation. And the next one, we convert the signal to the image. You can see in the feature. And the image can demonstrate a trail list in the ECG. And okay, and the next one, we also have the uh, handle the data imbalance for some specific classes like the LBB and SDE because they have limited the data in the total of the data set. So we need to identify these classes and duplicate, and the last one we shuffle this one to the data set to increase the data set size. And in addition, we also have the trees, the methods in the data augmentation, geometric transformation, color transformation, signal effect simulation, and the last one is random erasing. Yeah, to the model can study in the randomly with the data sets. And the next one after we change the data in the model, we apply the red cam to highlight the important reason that we can make a decision for classification of it of its label. And after we applying the red cam, we have to know some key features like the first one is atrial fibrillation, like you can see it's missing the P waves and irregular RR internal intervals. And the next one is IAVB is has the specific feature like a propose PR interval. And the next one is left bundle brand blocks has the block ways, and the right bundle brand block have the specific sub like the rabbit S parents in the V1 and V2. You can see. And the next one is radial atrial congestion have the radial P wave, and ventricular ectopic bit has wide and shorted with QR complex, and it's in addition have also the feature like radial ventricular bit. And we come to the last two classification with the STD and STE. STD is mean decreases ST segment, and STE elevated ST segment. Yeah, and we come to the DNS architecture with the with this architecture, we need to know the keys that the DNS can use the feature maps up on the receiving layer. You can see it's demonstrate on this formulation from the layer 0 to the layer of the last layer. And we come to the next is the result and discussion. So you can see on this table, I just talk about the two main types of the classes. The first one is high performance classes, includes the atrial fibrillation and right bundle brain block. With the atrial fibrillation has a high recon and high F1 score because AF have a clear freedom patterns, and so the model can detect most the case. And the last one in the high performance class is RBB has also have on the high the recon and high the F1 score with the with the value is to 0.91, And because the right bundle brain block has the distant waveform morphology, so it has lows missing the rate in the data sets. And we come to the next classes is challenging classes, which the first one is SD had a low recall is 0.59 because the SD had a limited the data, so it had a higher miss rate. And the next one is ventricular ectopic bit had also low the recall because this classification have the non-continuous patterns, so the the models also returns the low F1 score and recall in this classification. And to make deeper the insight, we come to the uh, confusion magic. We also talk about the high performance classes and challenging classes with the AF and RBB. You can see in this feature focus on the dark blue where has the number is 222 because this is too positive. It means the model can read it correctly in the case. So it's
Just a little reminder, you will have to wrap up in the next 1 minute.
okay. All right. Okay. Thank you for your
Yeah.
reminding. And okay. And the RB has also the high two positive. And the next one is SD and VRP because the limited sample and non-continuous, the parent cell has a low for negative, have a high. And we come to the last point is the conclusion and future work. So we'll try about the 80% with the F1 score, and it can achieve and credit correctly in some classes like the AF and RBB, and we also achieve the key objective. And in the future, we want to explore the vision transformer and make it and deploy it into the real world clinical. And that's all my presentation. Thanks for your listening. And if you have any question, feel free to ask me.
Hello, Pat. Yes, I have a question, and if you allow me to first to summarize my understanding and then to ask you. So first you clean the original signal to removing the noise. Then you transform the signal data to numeric data, the numeric matrix you mentioned. And then you transformed back this numeric data to graphics, once again to a picture. So I wonder if that's correct. I wonder how much of the original data have been lost actually, because there are so many transformation of data, and I assume you will tell me I'm right or not. I assume that a lot of data actually have been lost during this process. So would you explain a little bit more about this transformation from original data from the signal to the final data that you actually analyze?
Okay, all right. Thanks for your questions. Okay. Um. I th- yeah. I think your opinion does have has some correct. So, but because we use the DNS, So the dance model is designed and retrained on the image database. It contains a millions of the about millions of the 2D images. So and we use the 2D image can reverse the time and high frequency information and in addition, the 2D image can help us to uh, keep the external morphological feature. Yeah, when we give it to the Redic, and uh, I think in during the signal reprocessing and after that we converting to the image, they have some missing the data, the information in the records. Yeah, and I think when we apply the signal regressing, we have physics duration. So it's the standard duration for the ECG signal can see clearly about the waves in the ECG. Yeah, and that's on our answer.
Okay, thank you. Were there any misclassifications during this process actually made? Did you find something that was classified wrong?
Um,
Or you just didn't find anything that is incorrect?
uh, uh, you okay? All right. You missed. I don't talk about um the the model radix foliage, right? Valid.
That was the general to your research, not to my previous question. So identifying the diseases or um, some predictions for the patients based on their ECG, then you do it to identify something is wrong, right? So did you find that any of your conclusions were not correct based on the data? Because I assume that you used data for, how to say, not the new data from patients, but from data set. So
Yeah,
it's clear that this person with that ECG has a disease or not.
yeah,
And did you find any misclassification? So your approach says this is a disease, and original data says, okay, it's not nothing like that. So did you find kind of mistakes of your approach?
yes. Yeah, this is my limitation of the research. So I will talk to you in the future work. I want to use the uh vision transformer, yeah, to improve my accuracy. Yeah, because my dentist model had tries the accuracy is about 80%. Yeah.
Thank you.
Okay, thank you.
Okay, Bindia ma'am, do you have any questions?
When you transform your data from one platform to another platform, like you are telling you transform your data, so what sort of medium you are using for that particular work, for transforming?
Could you repeat the question
I
because
just
I can.
asked, I want to ask, when you transform your data from one platform to another, which sort of medium you are using?
Research. All right. Okay. Thank for
Okay,
your question.
you just come up your slide number 9 and 10.
Okay, number 9. is here.
Okay. Here you are transforming your data with AF and IVB. So, which sort of medium you are using? I'm just asking the question.
Yeah. Okay. Okay. I think we saw the in the um. Okay. Wait for me.
Which sort of algorithm you are using?
Using what? Using the
Fine. Next, please.
Okay, thank you so much for presenting, Fair. So for our next presentation, we have with us Jolina Espiritu. Jolina, are you present in the meeting?
Yes, ma'am.
Yes. Are you ready with the presentation?
Yes, ma'am. Allow me to share my presentation.
Yes, please. You can start sharing, Elena.
Is it visible now?
Yes, it is visible. You can start.
So, good day, everyone. I am Julina Bakita Spirito, and I will be presenting a research titled Improving System Reliability Through Closer Placement Optimization Using Steady-State Genetic Algorithm by minimizing PSI-B, PSI-P, and maximizing ENS. So, we all know that in today's modern society, the reliable delivery of electricity is essential for economic
Jolina,
growth.
sorry for interrupting you. I think we are facing some background noise from your side. Could you please go in the area where we can just quiet enough to listen you?
I'm so sorry, sir, because I'm in a shop because in our current location we have power interruption until 8 p.m. Sorry, sir. May I continue, sir, ma'am?
Yes, you can continue. Just try to be as loud as possible so that the background noise is not hearable to us.
Okay, yes.
Yes.
Okay, so again, so we all know that in today's modern society, the reliable delivery of electricity is essential for economic growth, social well-being, and public safety. However, power distribution systems remain vulnerable to faults and outages, leading to economic losses and disruptions. While traditional solutions exist, they often overlook the critical role of optimal closer replacement.
Jolina, you are not audible.
We cannot hear you. Yeah.
Jolina, are you able to hear me? I guess she's facing some sort of internet issue. Jolina?
Hello, ma'am. Yes.
Yes,
Am
are
I?
you facing some sort of an internet issue?
Yes, I guess, ma'am. Sorry.
Okay, so you can continue, please.
Am I audible now, ma'am?
Yes, you are audible.
Sorry for the interruption. So,
Yeah.
despite the numerous studies on power system reliability, a significant gap remains in addressing the inefficient placement of reclosers. So previous research have explored various methods, such as we can see in the screen, reactive power compensation and network reconfiguration. But these often overlook the crucial role of optimal recloser placement or relied on simplified models, which limits the generalizability of their findings. Specifically, the existing literature frequently lacks a detailed analysis of the impact of optimized recloser placement on multiple reliability indices simultaneously, particularly the interplay between the PSI-D, SIFI, and EANS. So this study proposed a solution to improve system reliability by optimizing an ACR or automatic circuit recloser placement using a steady state genetic algorithm or the SSGA implement in MATLAB as a meta heuristic approach integrating multiple key reliability indices like PSI-D, the SIFI, and the EENS into the optimization process. So the multi-objective fitness function aim to minimize the PSI-D, SIFI, while maximizing the EANS. The algorithm was validated using the IEEE 34-node test feeder before being applied to the real world or the Sintelco, which is the Central Pangasinan uh, Electric Cooperative. So the application of the SSGA resulted in significant improvements in SID values across all feeders. So we have three feeders, the feeder 2, 3, and 4. All post-optimization SID values were consistently below the NEA standard of 2,700 minutes per year for on-grid electric cooperatives. So the research introduced a novel approach of using the ENS to represent the number of connected customers at each node, providing a more accurate measure of outage impact. So the optimal locations identified for single ECR placement were 2C for the feeder 2, the 3A for feeder 3, and 4C for feeder 4. And for the recommendation, we proposed actions for Simpelco or the Central Pangasinan Electric Cooperative to implement the optimized ACR placement strategy at the locations identified by the SSGA or the feeder 2, 3, and 4 to achieve a more reliable and efficient power distribution system. So, and also, we propose to monitor system performance after implementation, tracking PSI-D, SIFI, and ENS values regularly to ensure continued effectiveness and facilitate continuous improvement. And for the implications and future directions, so the methodology is applicable to other distribution systems and provides a driven roadmap for infrastructure investment and grid modernization. So future research should explore the integration of renewable energy sources or the RES into the ACR optimization process to achieve a more sustainable and resilient power system. So that's all for my presentation. Thank you, ma'am. And sir.
Thank you, Julina. I can ask you what was the most surprising result of your study?
As we can see in the what do you call this, in the table that I showed earlier, we can say that with the use of the SIFI and SIFI,
We measure the outage duration experienced by the customers, and we also measure the how often the interruption occur. So analyze we did make drop to measure the amount of energy not delivered during outages, so that we can minimize what they call this the um, we can minimize the unscheduled, or what they call this the interruption of the outage.
Okay, thank you so much.
Okay, Bindya ma'am.
Okay, show
ma'am.
me your resulting part.
You were not audible, ma'am.
Am I audible now?
Yes, yes.
Can you please show your resulting slide?
Jolina, can you answer her question, please?
Sorry, ma'am. Can I ask for the question again?
Would you please show once again your results slides? The slide where, yeah, you show the results.
This one, ma'am.
Okay. So here you explain the different feeders values. With the help of these values, you are taking a comparative uh, decision. Is it so?
Yes, ma'am. And then applying using the AMS.
Okay. So there are three factors: best fitness, solution, and optimal location. Can you explain these three parameters?
So we have the three features. So we identify three locations or under the Santelco, and we gather the information because my co-author worked at the Santelco. So we got the results from the year 2020 to 2024 in order to compare the result.
And feather 2, feather 3, why you are using feather 3 multiplied by feather 4? It is multiplied, or it is just show you a sign in
Feeder
table
2,
10?
feeder 3, and feed.
In table 10, why you are using feather 3 multiplied by feather 4? Asterisk symbol is
Sorry.
over there in table 10.
Yes, ma'am. Sorry, ma'am. Maybe it's just a typo. So if there
Okay,
is
typing
no,
mistake. Okay,
uh,
fine. Okay, thank you.
thank you, ma'am.
Thank you so much, Jolina, for your presentation.
Thank
So
you,
up
ma'am.
next, again, we are having Elmar Noche to present his paper titled as Institutionalizing Artificial Intelligence in Education for Sustainable Development, a systematic review of higher education policies and practices in the Asia Pacific. So Elmar, are you ready?
Hi. Hi. Yes,
Eh,
I'm ready. Again, let me just
yes,
share my screen to you. Okay.
yes.
All right. Uh, there you go. Okay. All right. So again, good afternoon. Um, I'm back again for my second presentation for the paper entitled Institutional AI and Educational Sustainable Development. This actually paper is I'm working with Dr. Renato E. Salcedo, our Vice President, and also a research fellow in Seji University of Malaysia. So basically, what we have here is on more in paper review. Okay, So more in mapping how Asia Pacific University are embedding AI. So this review synthesized at least 6 to 8 peer review studies, policies, documents, government reports from 2018 to 2024 to assess how unevenly AI is being institutional across Asia Pacific in higher education, and whether those efforts align with education sustainable development principles. So, as stated on the centralized thesis of the review, institutionalizing AI will not automatically produce education for sustainable development. That requires intentional design and political will. So that's actually about the paper itself. So in regards to this one, this slide frames the core tension that it motivates the review. There's a promise and there's a peril. So starts with the scale point that Asia Pacific holds more than half of the world higher students education. So whatever happens, shapes global outcomes. The present AI is actually being said on that one. So uh, in this one, promise side, adaptive and intelligent tutoring, personalized learning, AI can widen access for marginalized learners, machine learning, support sustainable science, and data tools optimize the resources as well. On the parallel side, the same system can reproduce inequality at scales of erode academic integrity. So it actually create uh, what we call a epistemic dependency. Actually make a post-colonial point. Okay. So those are the things that we have. So takeaways here, AI is not inherently good or bad, but basically this outcomes can have some issues as well on the objective. Okay. So next one. So we have three theories and four analytical dimensions. So it's the three theoretical tradition are brain together. The neo-institutional theory, okay, explains why institution adopt, okay, and AI pressure from government peers and international bodies as well. And ESD competency framework supplies the normative yardstick. It actually does build sustainable competency and diffusion and acceptance theory, and also the Rogers and Davis explains in Bailing constraint factors that an individual are operational into four measurable dimension on a dark panel. Structural curricular research capacity and what we call ESD. ESD alignment is actually green. Dimensional review cares most about one's turnout's weakness. So those are the things. So those are the 60 resources that we have. So the transparent reproducible screening funnel that we did, or the Prisma that we have, uh, there are 2,847 records identified across 9 databases that we did. Scopus, Web of Science, ERIC, IEEE, and other plus, literature that was got. And then we try to, minimize it and then try to have our criteria for it. And based on the slide that you can see, and then evidence base concentrated on East Asian Oceania, as you can see, China alone for 20% of source, together with Australia, Singapore, and South Korea and Japan. Those are the empirical study that we have found. So China dominates it at like 19 sources, Australia 11, Singapore like 7, and then Japan is 6. Philippines has actually 5. And what we have here is the result that we actually did see. is 4 pathways by which AI becomes embedded. Well, it's stated on the literature review. Curriculum integration is number one. Second is the research infrastructure. Third will be the policy formalization, and then fourth will be the faculty capacity building. So those four are very evident on the four pathways which AI can be embedded. Okay. Now, the next one is AI is taught for competitiveness, realized for sustainability. So first is a single most important findings that we did on the pathway. So the headline stats at the top right, if you can see, um, there are 52 resources that we have. Okay, and addressing the curriculum, only 14 to 27 showed up deliberate link between the outcome. So it actually led on somehow AI model is being taught. So that's actually what we have here. The critical gap across all three models, AI curricula and frame around technical skills are, in economic competitiveness. Sustainable appears if all in the isolated electives, not as a core learning outcome. Okay. So five domains where institutionalization is won or lost. We have the barriers, we have embedding conditions as well. The table shows here, okay, the policies, governance, infrastructure, human capital, institution, culture, and also on ethics, okay, actually shows there. Okay. Now for the three tiers, uh advanced integration for Singapore and Australia, we did found that also emerging integration in China, South Korea, Japan, and India, and nascent integration for Philippines, Indonesia, Vietnam, and Thailand and Pacific. So the language of sustainability is increasingly present in AI policy, but concentrate on mechanism to translate into curricular research and governance remain underdeveloped. Countries cluster into three tiers, as you can see on the slides. So on this one, three conclusions from the 6 to 8 sources that we have. Technical logical dominates. AI institution proceeds along technical and economical lines with sustainable and equity large secondary absence from dominant policies framework. Also, enablers, distributed as well. The policy infrastructure, faculty support, ethics, governance, cluster, high income context risk, deeper education, inequality across regions. That's actually true. And ESD requires intention. So institutionally, AI will not automatically produce education for sustainable development. And that outcome demands deliberate design, normative and commitment and political will. So evidence-based action for three stakeholders group, national governments, higher education institution, and international organizations. So resource AI strategies aligned with ESD and SGD4. Institution-wide literacy, technical and ethical as well for higher education and international prioritized capacity building for Pacific and lower income for SE on Asia. So there's a lot of things there that we need to work on. But for RRL, we have found out that, by upfront about limitation, it strengthens its capability. The biggest, things that we need to work on this one is why do we need to have this kind of research? Probably we see some things where we can get insights on it, especially now that the wide use of AI in higher educations that actually center flourishing or ecological sustainability for global things as well. So it's like you know uh, a review of related literature on how we can use properly AI and adapt on it. So that's in my um, presentation. Thank you so much. I'm open for your question.
May I ask you, yes, something related to your final words actually. Did you identify any best practices that could be transferred across countries, maybe in the region that you researched during this study, or maybe beyond, so globally? So, did you identify something that could be transferred?
Yeah, there's a lot. There's a very, there's promising processes in other countries that they adapt on AI usage, especially in China. We did see a lot of things, especially on how the laws are being, governed on usage of AI, especially in education. So there is sort of like not really relying on AI, but trying to teach how to use AI properly on most of the 68 resources that we have. Is that's the point of their telling that there is an AI here, but you need to use it properly, not rely on it. So, but the problem is the checking for AI, outputs, and also the government itself, or the law that have some, things in the Philippines. I think we still working on it, but there's a lot. So there's a promise, adaptive in learning intelligence, those kinds of stuff. Machine learning advances, basically creating programs, creating systems is very easy. It's just that we need to properly prompt that. So prompting skills is one of the things that they need to see here in the Philippines. Also, that's one of the things that I see on the 68 resources that we have.
Thank
So
you very much. It was very interesting.
thank you, ma'am.
Yeah.
Okay, your work is really good. If it is work in worldwide level, then definitely it is helpful. But can you really think the adaptive learning is good for uh, not only sustainability development in overall growth of worldwide level? So what
Uh,
the path? Yeah.
yes, ma'am. Actually, that's a very nice question. Based on the literature review we did, it's sort of like on in between. There is papers that's telling that it's a very best thing that you can have that for producing much more better students using AI, because they will have like they can focus on other jobs, or they can focus on other tasks that they do. But there are some, based on the 6 to 8 resources that we have, telling that yeah, they can focus on what they can do a lot more, but they or keep on relying on that, and then eventually their critical thinking will not be, practice, something like that. They cannot, on the long run, they said that the critical thinking of a certain student will be affected using AI. Yes, you're correct. It's making the job easier. You can have a much more time to do a lot of things, create more things rather than focus on one task. But the critical thinking will be jeopardized on that. That's based on the summaries that we have did. So that's why they're trying to limit it, and then they're trying to create some laws and other uh you know uh, approach on how to deal with it, those kinds of stuff.
Okay, yes, you are right, but responsible AI should be there. When you and other students those are using AI, definitely they have to be responsible and user ethical. Without these, it is very hard for us.
You're
What
correct.
I think so. Okay, thank you so much.
Thank you.
Next,
Thank
please.
you.
Thank you so much, Elmar, for presenting your work.
Thank you. Thank you so much.
Okay, so for today's last presentation, we have with us uh, Fei, Wei, 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 Ong. So are you there in the meeting? Okay, let me
Let me
check.
share my PowerPoint presentation.
Yes, so she's here to present her paper titled as YOLO version 9 based, one second. Yeah, YOLO version 9 based multi-object tracking system using improved deep sort with glow association and re-ID memory based class filtering. So yes, you can start your presentation. Hello, am I audible? You can start. Yeah.
Can you hear me?
Yes, you are audible.
Good afternoon, all of my respectful professor and teacher. May I introduce myself? I am Popiya. I am from the University of Computer Studies, Yangon in Myanmar. I am PhD candidate in UCSY. My supervisor is Dr. Tenzado. Today, I would like to talk about YOLO V9-based multi-object tracking system. You see the improved DSOL with the GIOU association and re-ID memory-based class filtering. There are 10 outlines in my presentation. I would like to propose my abstract. Multi-object tracking systems are created in various real-life applications, including smart video surveillance, traffic monitoring, robotics for analytics, customer behavior analysis, and drone control. Most MOD systems are created by combining DSOF and YOLO series. The original DSOF relied on IOU association-based machine and fit threshold deletion algorithm often leads to the incorrect association, premature thread removal, and frequent ID switch under the occlusion. This system proposed by using the GIOU for more than reliable geometric association and enhanced filtering algorithm. Experimental evaluation achieved the more stable and accurate tracking performance compared to the original source system. In my research introduction, mostly modern MOD systems create the detection and tracking architecture. First, the detector identify the candidate object in the frame, and then tracker associate this detection across the type to maintain a stable entity. Deep learning-based object detector has significantly improved the accuracy and speed of the multi-object detection. Simple online and real-time tracking with the DSOL is a popular online MOT algorithm that uses the common filter for motion prediction with the D-appearance empathy for data association. The original DSOL trusts the targeted object more accurately and it stays far from entity instability in complex environment. In the result, the IOU association improved the machine reliability compared to the IOU machine, while the enhanced the filtering algorithm use the classification and motion uncertainty for updated trust management and re-ID memory buffer with the feature history recover lost entity and reduce the ID switch. There are research challenges, and DSOF is maintained by associated detection across the frame using the IOU-based geometric similarity and appearance distractor. IOU have the critical limitation when the bounding bounds do not overlap even if they are sparsely close. And in the unreliable machine, causes the tracker to the mid-associated detection of frequent ID switches. And then temporarily the occlude and partially visible objects are often deleted and reinitialized when they reappear, leading to ID switch. And next point, DSOL does not incorporate semantic class validation or uncertainty estimation, and making it vulnerable to mismatch between the visually similar. This limitation highlights the need for the enhanced tracking approach that address the IOU inability to handle the non-overlapping the process and for the class consistency. Let's move on to the next slide. In my research objective, to improve the accuracy and reliability of object association by replacing the original IOU-based machine with the GIOU-based strategy. The second one is to enhance the robustness of the trust management by developing the advanced filtering algorithm. And the next point is to reduce the ID switches and trust fragmentation caused by the occlusion, fast object motion, and data noise. And next, to prevent the premature deletion of the billet track by replacing the dissolved threshold deletion mechanism with an adaptive decision process based on the feature similarity and common filter uncertainty. And the last point is to maintain a semantic consistency across the frame by ensuring that detected object class match the store track class, thereby reducing the cross mismatch and fault association. Let's move on to the next slide. And my contribution of the proposed research aim to develop and implement multi-object tracking system based on the improved DSOL framework and YOLO V9. The main contribution is to create the GIOU-based machine to overcome the IOU limitation, and this research aim to develop an enhanced filtering algorithm with a class consistency, uncertainty control, and feature history. Overall, this research seeks to design the adaptive deletion strategy combining time, uncertainty, and class validation. The performance evaluation will conduct to achieve the more stable and accurate multi-object tracking system than the original DSOL. Let's move on to the next slide. There are 4 stages in my research, and the first step is to import the video sequence, and the second step is to detect object. The object by using the YOLO V9, and the next step is to trace the object by using the dissolve. And the final step is to output video or with the consistent identity. Let's move on to the next slide. In this slide, I will explain the overall figure flow is shown in the figure 1. In the first stage, the YOLO V9 buffer object detection and generating bounding bounds along with the confidence score and class level for all the targeted objects in the frame. In the next step, common filter is applied to predict and the motion state of the is the active track based on the previous trajectory to produce the 3 results. Master are then refined through the common filter update, and master and detection are passed to the next machine based on the GIOU. In the GIOU state, in this state, the HPDA will count the number of frame that is occurring in the video. The HPDA is less than 3. These tracks are the new tracks. Otherwise, the system match the detection. Otherwise, the system match the detection object and prediction object to produce the 2 results, master and unmaster. If the information, the match is updated in the common filter update, otherwise the system apply and has filtering and trap management strategy. Finally, the state of the master are then refined through the common filter, common measurement update, and add frame into the fully the frame to create the multi-object tracking video for all the frame. The proposed MOD system improve the tracking accuracy in terms of involving occlusion, fast motion, and detection instability. Let's move on to the next slide. In this slide, I will explain MOD 60 and COCO dataset. The proposed system use YOLO V9 model that is trained for the 100 epoch on the COCO dataset with the input resolution of 640 and 480 to detect multi-object. The COCO dataset includes approximately 330K inmate annotated for object detection, segmentation, and captioning with the 80 object category. In the research paper, YOLO V9 is used to detect the following 40 object category. The MOD 60 MOD benchmark dataset contains 40 different video sequences recorded in unrestricted real-world setting using the both static and movie camera. Let's move on to the next slide. There are 2 evaluation metrics to measure the performance of the proposed MOD system. The first one is the multi-object tracking accuracy. It's a standard metric used to evaluate the overall tracking accuracy by combining multiple type error, including the false positive, false negative, and entity switch. It is calculated as the following formula. A higher MOTA score indicates whether the tracking performance reflects the system ability to minimize misdetection, false alarm, and tracking inconsistency. And the next evaluation metric is the entity F1 score. Entity F1 is the measure the ability of the tracker to maintain a consistent entity assignment across the frame. It is computed as the following formula. A higher entity F1 score demonstrates better the entity preservation, which is critical in application requiring the robust tracking. Let's move on to the next slide. This slide is the result of IOU-based machine and GIOU machine of the MOD system with the simple filtering algorithm are analyzed. The overall experiment showed that the use of the GIOU for the association enhanced both the tracking precision and entity reliability when compared to the IOU machine in the DSOP system. Let's move on to the next slide. This slide is the analysis result of the GIOU and GIOU with the enhanced DSOF on the MOD 6011 video. In the MOD 6011 video, GIOU with the original DSOF object ID 212 is switched to the object ID 220 and 212. In the GIOU with enhanced DSOF object ID is consistent. This slide is the analysis result of the GIOU and GIOU with enhanced and DSOL on the MOD60 video. In the MOD60 video, GIOU with original DSOL object ID 87 is switched to the ID 123 class level car. In the GIOU with the enhanced DSOL object ID 87 is consistent. This slide is the proposed enhanced the DSOL achieves the higher MOTA score and IDF1 score across all evaluated sequence than the original DSOL. Let's move on. Let me conclude my presentation. This paper proposed and improved the multi-object tracking system that combines the YOLO V9 for multi-object detection with an improved DSOL tracker to achieve the robust and stable identity tracking in complex video environment. The proposed MOT system enhances both the tracking precision and identity stability compared to the original MOT system based on the simple filtering algorithm. The improved performance results highlight the advantage of the proposed MOD system through the integration of the GIOU and improved filtering algorithm to increase tracking accuracy, decrease entity switch, and reduce the track fragmentation. Overall, the proposed MOD YOLO V9 based multi-object tracking system provides a reliable and effective solution for multi-object tracking application. Thank you, teacher.
Thank you, Fai, with about your presentation. I was wondering, can you briefly explain this advanced filtering algorithm you mentioned that has been developed for the study or during the study? So what's the main purpose of it or how it works? Just few words. It seems this is an important part of your work.
I'm prepared the main data set on related challenges in the research include the limited data set diversity, occlusion, and complex object movement. These challenges can affect the training and evaluation that performance of the proposed object tracking system, and therefore
Your voice is cracking very much. So you can put your answer in the chat box. Are you able to hear me?
Yes, teacher.
Okay, so you can answer her question. Your voice was cracking when you were answering earlier.
I I I will prepare the reset. I prepare the reset. Um, the yes. Um, in-
No, your voice is cracking a lot actually. So what you can do is you can answer the question in the chat box and you can stop sharing and we'll move on to the last presentation for today. Okay, I think there's no
Yes, teacher.
connectivity. You can put your answer in the chat box, please. Okay, so for last presentation we have Aksh Modi. Are you present, Aksh?
Yes, I'm here.
Yes, you can
Yes.
start sharing, please. And as you have missed a chance, so you have to wrap up within 7 6 7 minutes hardly, as we are time bound already. Time.
Yeah, sure. I will.
Yes.
Is my screen visible?
Yes, it is visible.
So yeah, good evening, session chair, esteemed colleagues, and the guests present all over here. I am Aksh Modi, representing Department of Data Science and Engineering at Manipal University, Jaipur. On the behalf of my co-authors Agrem Suryan Sahil and Dr. Malvinder sir, I'm excited to present our research on the real-time coral bleaching classification. So our work directly addresses a critical bottleneck in marine conservation, the tension that is between highly accurate environmental monitoring and the strict computational limits of the edge devices. As we have developed a lightweight YOLO-weight small classifier that achieves a 89.84 top one accuracy with just a 2 millisecond inference time. This research forms the foundation of our broader Aquatrace initiative, proving that we do not have to sacrifice accuracy to achieve the edge deployable speed. So, going for the problem to understand why behind this model, we have to look at the ecological urgency. Coral reefs are highly susceptible to environmental disturbances, and rapid human-driven climate changes are severely threatening this ecosystem. So we need scalable automation monitoring. Currently, the state-of-art approaches heavily rely on the vision transformers or efficient net models. While accurate, these models are computationally intensive for autonomous underwater vehicles operating on the battery power, which are limited. Without cloud connectivity, the severe latency and the rapid battery drain on these models make them entirely unfeasible to deploy on the edge. Our solution pivots the YOLO because it frames detection as a single regression problem, processing an entire image in one fast forward pass, which is critical for real time habitat monitoring. So going for why this matters and where this matters. So looking at the current literature, we see a clear gap as the NOAA Vision Transformers model hit around 85% accuracy but requires over 85 million parameters, making them so massive. Earlier YOLO frameworks like the YOLO V5 or specific YOLO V8 Nano implementation show promise speed but suffer a massive accuracy drop. Even NOAA recent YOLO 11 and CLS achieves around 89.8% accuracy but still require extensive architectural validation for search constraint setups. So our goal was to find the perfect middle ground, outperforming the heavy transformers while maintaining the raw speed of the lightweight CNNs. So going for the model selections, when engineering the solution, we evaluated the YOLO-V8 family by Ultralytics. We specifically utilize YOLO-V8 S CLS, which discards bounding box regression, heading in favor of the single classification head, streaming the architecture for our binary task. Finding the right variant as an exercise in balancing constraint, we initially tested it with the YOLO Viet medium variant, but immediately as we encountered the out of memory errors on the available 4G RTX setup, we then tested the nano variant, but rejected it after a steep 5% drop in the accuracy. The small variant YOLO Viet SCLS emerged as the best choice. It offered the balance between the low memory footprint and high inference speed and robust classification accuracy. Going for the dataset we have used for our dataset, we relied on the NOAA Pacific Island Fisheries Science Center's Ecosystem Science Division dataset. This is a highly reliable dataset because the ground truth labels reflect genuine expert agreement. Built using targeted annotation protocols, we maintained the official NOAA split of 70% training, 50% validation, and 50% testing, resizing all the inputs to standard 224 cross 224 pixel. Training was conducted locally via CUDA. We applied binary cross entropy loss alongside aggressive regularization strategies to prevent overfitting. This include dropout in the final layer, L2 at decay, and the geometric data augmentation like random horizontal and vertical flips. We also utilize early stopping and patience of 10 epochs to ensure optimal generation. Going with the operational pipeline, our pipeline transformed the raw images into actionable conservation data through three distinct stages. First, the acquisition and pre-processing images are ingested and standardized. As we discussed, inference, the YOLO V8 CLS model process the patches, averaging roughly 7 milliseconds per image in the pipeline, well within our real-time threshold. So the actionable output we have got is this is where the system adds operational value. We designed a batch level stress score heuristic instead of just outputting the raw label. The system aggregates batch labeled confidences across all images in a sector to generate a single actionable conservation alert. Going with the results, the quantitative results exceeded our baseline expectations. The model achieved an overall validation accuracy of 89.84%. Looking at our confusion metrics, the model is highly precise. And when analyzing all failure models, we noted that the majority of our positive involved naturally pale corals or something experimental partial early stage stress, which is an incredibly difficult to distinguish even by human analytics. Crucially, the accuracy is paired with the extreme efficiency, uh, with require just 2 milliseconds of the inference time per image on RTX 3050, yielding a real-time throughput of 142 frames per second with a compressed model size of 10.2 MB and a VRAM of the 0.6 GB. We completely resolved the earlier memory bottleneck. Going for the comparison between the NOAA baseline model, to put this into perspective, we benchmarked our model against the NOAA's official classifiers. Our YOLO V8 CLS outperformed both of them, and while NOAA's YOLO 11N is technically faster, it plateaued an 85.2% accuracy. NOAA's heavier VIT classifiers are only achieving 83.7%. This proves our core thesis lightweight CNNs can absolutely outperform complex transformer-based models. So, going for the limitation and the future scope, while highly effective, we recognize current limitation. The model is highly optimized for the Hawaiian region based on NOAA's data. So our immediate next step is to building a transfer learning pipeline to fine tune the base models for different geographic region with minimal data. We also plan to move from the binary classification to identifying 5 specific stage of coral bleaching and adapting our single image pipeline to processing live video feeds using GS streamer. Finally, we are exploring aggressive quantization to deploy this on ultra low power microchips like ESP32. So, in conclusion, we have successfully engineered a complete methodology that navigates the difficulty tension between the analytical accuracy and the edge efficiency. So, by utilizing the YOLO V8S classifier architecture and our custom stress score pipeline, we have built a robust field deployable solution for machine conservation. So thank you, and I'm welcome to all the questions.
Okay, do anyone have any questions for him?
I don't have questions.
Okay, Bindya ma'am.
Yes. You are using a different. Can you please come up your first slide, like your title slide?
Yes.
You are using YOLO for like deep learning using the. So you implement it with the help of some sort of data sets. Is it so?
Yeah, we have implemented it with the NOAA classifier dataset that I just discussed about.
So, uh, from which algorithm and which concept you are using for this YOLO framework?
Sorry.
Uh, uh, which, which algorithm you are using for that particular framework?
So for the uh, framework that we are using, we are particularly utilizing the Ultralytics YOLO V8 framework, that is the small classification model. So what we have do is the we have feature extraction, that the algorithm uses the YOLO V8 darknet backbone to extract highly detailed structural and texture feature from the underwater image patches. Then we have the classification head. Unlike traditional YOLO models, the YOLO V8S classifier variants completely just discards the boundary box regression problem. So instead, it routes the feature through a global average pooling layer into single fully connected classification head output. So by using this and the loss optimization function that I just discussed about the binary cross entropy loss, uh, we developed this whole framework.
Okay. As I see your references, your first reference is as your base paper. Is it so?
Uh, Sorry.
Your first reference is your base paper, where you find your like your objective of this paper, from which paper you read, and after that you analyze that you have to do the work on that particular concept with using a YOLO framework.
So we have find out this from the data set, the references they have provided. So the first paper uh, it provides is the base paper we have used.
Okay, can you open this paper?
The screen is not visible actually. You need to share the entire screen for the
Okay,
visibility.
okay.
Yeah. You can stop and reshare again.
Okay,
Yeah, it is visible.
So is
yes,
it
now it is
visible?
visible.
Yes.
Okay, so here you can we come up in abstract? Yes.
Yeah,
Yes, it is used YOLO 9 and YOLO 8. And
yeah.
you are using in your paper
YOLO 8.
YOLO 8.
Yeah, YOLO 8 small variant.
Okay, fine. Okay, fine. Fine.
Oh,
Yes. Thank you so much.
okay.
Thank you so much,
So
Aksh,
much.
for your presentation.
Thank you.
Yes. So I think we have come to the end of this session. So I will sincerely thank all our authors for their excellent presentations and valuable contributions, and all the participants for being an important part of this international conference. I truly hope that this session was an insightful, engaging, and inspiring session for everyone. So, on behalf of the entire team, we thank you for your continued support, not just for this edition, but for all the previous editions of TIBS. We look forward to welcoming you again in the next version, 2027. All presenters will be receiving their digital certificates through their emails within 2 working days, and the publication will be live within 7 to 8 months. So, we kindly request your cooperation with the TIBS 2026 team. I would also like to extend my sincere thanks to our session chairs, Dr. Peppa Petrova and Bindya Jain ma'am. Both of you, thank you so much for joining us today. And this is a small token of appreciation on behalf of Team TIBS and Global Knowledge Research Foundation and partners to both of you. So, thank you all once again for your valuable presence. And before we officially wrap up with the session, let's capture this as a quick memory. I kindly request everyone to please switch on your cameras for the group snapshot of this conference. 1 second. Yes. I request everyone to please turn on their cameras. Yeah, okay. Okay, thank you so much, everyone, for joining. Stay safe. Take care, everyone. Thank you to both the session chairs. Bye, ma'am. Bye, everyone.
Thank you. Bye bye, everyone.
Bye.
You.
Okay, have a nice day, all of you. Thank you so much.
Same to you, ma'am. Same to you.
Same to you.